good afternoon. This is our presentation about space exploration with precaution. My name is Divya Kolagundi,
Sarah Vitoriani,
Clarice Cowie,
and Hafsa Ahmed. So what is space exploration? Space exploration is investigating our universe beyond our atmosphere. Curiosity and innovation fuel people to explore new planets, yet this exploration comes with the cost of contaminating environments that we don't fully understand.
Is it ethical to risk contaminating other planets while exploring space? Human exploration is important for progress and discovery, however, we must take precautions. If we contaminate other planets, we can lose the chance to learn about other planets, and that's why it's so important to explore responsibly and protect other environments so we can reach further into space.
Our solution to this is to weigh risk against opportunity. Yes, environmental damages are observable occurrences, so it is important for us to collaborate with one another in order to guarantee that exploration can respect environmental concerns. Space has its economic benefits. For one, asteroids are worth lots of money, and asteroid mining is a rising industry, which could potentially stabilize developed and developing economies. This chart here is a recreation of a larger chart by Matthew Weinzierl, who is a professor at Harvard Business, which shows companies who partake in the asteroid mining activity. As you can see by the large value of 11 to 50 million USD, just shows how much asteroid mining really makes. Of course, space has its economic limitations. Large investments are required. Exploring further already has a huge price tag, and not only that, other areas like technology, sciences need their own funds. Tying to the huge price tag, larger organizations like NASA are usually the ones who go forward with these larger projects.
Technology plays a big role in making space exploration more effective. It improves range resolution, which allows us to explore further distances and get clear results. It also reduces errors, helping scientists make more reliable findings and help make mistakes in research. This image shows the ACT America 2016 campaign, where aircraft use advanced instruments to collect data on carbon dioxide and the weather in the US. The flight paths in red and blue show how the planes gathered information from different altitudes and locations, allowing scientists to understand how carbon dioxide moves through the atmosphere. It also shows how technology and research flights make data more accurate and helps with space exploration. Now let's talk about some of the major limitations technology presents in space. When it comes to technology, first there's the issue of high costs. Developing and maintaining communication systems for space missions is extremely expensive and can delay important projects. Second, we face challenges since space is a harsh environment. Contaminating systems that can be repaired there is very complex. And lastly, space missions gather huge amounts of data, and analyzing and managing it can be very difficult. This is why technology allows us to explore space, but it also brings serious limitations that we need to consider.
Space exploration can also cause health concerns. From this image from Nisha Charji, who is an MD student at the RIK College of Medical Science, is showing a gut. From this side, we can see a healthy gut. The healthy gut has tight junctions and proteins, allowing for homeostasis. This allows for water and nutrients to pass through the cell while harmful substances are being kept out. On the other side, we can see what radiation has caused the gut. The seal between the cell has loosened, which means unwanted substances are being slipped into the bloodstream. This can cause inflammation and metabolic disorders and autoimmune responses. Essentially, all of this can lead to cardiovascular damage and increase your risk for cancer. But there is solutions. One solution is the use of ON01210NA, which is a radioprotective drug. From this graph from Anthony Kang, who is a researcher from the Fields Institute for Cancer Research, is demonstrating vehicle IR, which is right here. And it is showing a huge drop in colony formation. So basically, cells can't recover well from radiation. But when the drug is given before radiation, demonstrated from this line right over here, colony formation is a lot higher, meaning this drug helps protect bone marrow cells from radiation. Another solution is the use of dietary supplements, which works by achieving radioprotection even in places with high LET radiation.
Now we can move over to environmental concerns. First off, Aaron Bronstel points out that even a small amount of bacteria stuck to a spacecraft can spread across the planet, wipe out any life that is already present, or contaminate any samples that are being brought back. Joshua Tallis also highlights that 17,000 pieces of catalog debris in the low Earth orbit could increase the risk of collisions that could destroy satellites and harm orbits. Some can even enter planets and disrupt their environmental observations. Michael Oldland from the NASA Langley Research Center uses this graph to show CO2 data, emphasizing that even small equipment flaws can bias data and their environmental observations. Our solution is to enforce stronger international policies. We need rules to prevent spacecrafts from spreading bacteria or harmful materials, invest in technology such as deorbiting old satellites, and ensure countries and companies are held accountable under the same shared standards to keep our space safe.
Going further into space is important in order to advance in areas of economics, technology, health, while taking consideration of economic and environmental concerns. Thank you.